All right, 2.3, we're going to talk about conditional statements. The objective, students will be able to recognize and write conditional statements, converse, inverse, and contrapositive of those statements. So first of all, a conditional statement, well, that is just simply an if-then statement. Okay, so an example here is, if you are in this class, then you are taking geometry. And conditional statements have two parts. They have a hypothesis and the conclusion. The hypothesis is the if part of the statement, and the conclusion is the then part. Notice, though, when I am talking about the hypothesis, I do not include the if, and when I'm talking about the conclusion, I do not include the then. It's just the part that comes after each of those words. So, for example, if I was to identify the hypothesis and the conclusion, I'm just going to color code this. Let's make the hypothesis blue, conclusion red. The hypothesis would just be, it is sunny, and the conclusion would just be, it is daytime. So, once you guys identify the hypothesis and the conclusion, for if y minus or equals 5, then y equals 8. You should be able to do it rather quickly. So I'm going to go ahead and put the answer up, see if you figured it out. You should have said that y minus or equals 5 is the hypothesis, and the conclusion is just y equals 8. Do not include the if and the then, because later on as we start to switch things up, you're going to need to know to leave the if and the then in the same order. Okay, let's write this as an if-then statement. So we have an integer that ends with 0 is divisible by 5. So how could I write that as an if-then statement? Well, if an integer ends with 0, then it is divisible by 5. Okay, I kind of made the first part my hypothesis. Kind of see like the integer that ends with 0, and then I made this my conclusion. So that's kind of how I broke it up. And sometimes you're going to have to add in some nouns or something. So I want you guys to try and do practice number 2 here. A square has 4 congruent sides. How could you write that as an if-then statement? My recommendation is, if you say it out loud and it doesn't make sense, it's probably not right. So try and write it in a way that would make sense. You can go ahead and do that and pause the video, and I'll put the answer up in just a second. Okay, well, I'm thinking the square is the hypothesis and the has 4 congruent sides is the conclusion. So I'm going to say, if a shape is a square, then it has 4 congruent sides. Okay. Truth value. The truth value is the truth or falsity of a statement. And the main thing to know here, in order for something to be true in geometry, if it's true, it is always true. Okay? If it's sometimes true, then we would not say that's a true statement. That's actually a false statement. All right? So it needs, if it's true, it needs to always be true in every circumstance. All right, let's go to the next page. So let's talk about the truth value of these statements. So the first thing here says, if it is sunny, then it is daytime. Is that always true? Well, it's usually true that if it's sunny, then it's daytime, but it's not always true. There are parts in the world where the sun actually stays up for 24 hours in the middle of the summer. So this is not always true. And the second one, is this one always true? If y minus 3 equals 5, then is y equal 8? Yeah, that's actually always going to be true. So we could say always true. Oh, and by the way, since this is not always true, we would just say that it is a false statement. Okay. So a counterexample is an example that shows the hypothesis true and the conclusion false. Let me show you what I mean by that. We're going to have a counterexample for this first statement. and we're going to let the hypothesis stay true, but we're going to contradict the conclusion. So if it is sunny, then it is daytime. So we need to think of a situation where it is sunny, but is not necessarily daytime. And Alaska is actually a perfect counterexample to if it is sunny, then it is daytime. Because in Alaska in the summer, it is sunny, so this part's true, but it is not necessarily daytime all the time, right? I was there, and it was like 11:30 at night, and the sun was still out. So it's not necessarily sunny just because it is, or it's not necessarily daytime just because it's sunny. So we have an example here. You guys can think about this. If you go to Buckingham, then you live in Vacaville. So I want you guys to think of a counterexample to this. Now remember, this part needs to stay true. So you can't say, oh, counterexample to this is Vaca High. That doesn't work because that would contradict the hypothesis. We don't want to contradict the hypothesis. We want to contradict the conclusion. So think of a counterexample to this statement, and I'll throw a couple up in just a second. You can pause the video if you want. All right, some counterexamples would be Fairfield. There's a lot of people that live in Fairfield but go to Buckingham. There's a lot of people that live maybe in Dixon and go to Buckingham, or live in Vallejo or Winners. Those are all counterexamples because they still go to Buckingham. This part's still true, but they don't live in Vacaville, so we contradict the conclusion. All right. Let's talk about what a converse is. A converse is when we switch the hypothesis and the conclusion. Just switch them. So, instead of saying if it is sunny, then it is daytime, we would say if it is daytime, then it is sunny. All right, so we just switch the order. That's all it is. So you may want to pause the video, see if you can write the converse of these two statements, and then check back and see if you got it right. So go ahead and pause the video now, and I'll put the answers up in just a second. Okay, so for the first one, it should have been really easy. Just switch it. So it says if y equals 8, then y minus 3 equals 5. The second one is if two lines are skewed, then they are not parallel and do not intersect. Now I want to show you, you didn't have to do this, but this is just what I did. I left the two lines part in the hypothesis, and that's really okay, because the two lines and the they are interchangeable. So I just think it sounds better by saying if two lines are skewed, then they are not parallel and do not intersect. But you could have just said if they are skewed, then two lines are not parallel and do not intersect. But it just doesn't sound as good, so you can change it up these two terms because they're interchangeable. Okay, the inverse. The inverse is the negation of both the hypothesis and the conclusion. So this is when we will say the opposite truth value of it. So, for example, the inverse of this guy, if it is sunny, then it is daytime, would be this. If it is not sunny, then it is not daytime. And it's at this point that somebody will say like, oh, well, that's not true, and that's fine. But notice, all they're telling me to do is write the inverse. They're not telling me to figure out what the truth value is. I only care about what the truth value is on these problems when they actually tell me to care about the truth value. Otherwise, I'm just writing the statement how they're telling me to write it. So you guys go ahead and try and do practice B here, and see if you can write the inverse of that statement. Alright, so here's what I wrote. If you don't go to Buckingham, then you don't live in Vacaville. That is the inverse. I negated both the hypothesis and the conclusion. Alright, next page. Alright, last term here is the contrapositive. And the contrapositive is the negation of both the hypothesis and the conclusion of the converse. So now we're going to switch the order and negate both statements. So let me give you an example. Write the contrapositive of if it is sunny, then it is daytime. this would be if it is not daytime, then it is not sunny. Okay? That's the contrapositive. So what I want you guys to do is write the contrapositive to that statement. If you go to Buckingham, then you live in Vacaville. Go ahead and try that. I'll put the answer up in just a second. Okay. So you should have wrote, if you don't live in Vacaville, then you don't go to Buckingham. That's the contrapositive. All right, last thing is, let's talk about what a logically equivalent statement is. These are statements with the same truth value. And when you write conditional statements, they will have the same truth value as their contrapositive, and the converse should have the same truth value as the inverse. So these should always match up. For the summary, I would like for you guys to rewrite this as an if-then statement, and then I want you to write the converse, inverse, and contrapositive, and determine the truth value of all of those. So you do those, you can check with me in class to see if you did that right. Okay, see you guys in the next video.